Thank you, Mikhail. Good afternoon, everyone. My name is Fedor Mutiev. I do development and implementation of machine learning for finance audience. I'll be talking about how we got unique experience creating products, implementing machine learning at Sber, and how we've learned to combine the power of machine learning and product expertise, who know about some future events in the bank. So being able to leverage this knowledge has become critical for prediction. It had to be taken account of. And I'll also tell you how we follow this path, what we have as regular tools. I'm going to disclose that. So the situation. The Competence Center predicts a large number of income items. There was more than 1 million values. So in the past, it had always been done in Excel, SQL Server, another system, just like in many organizations. Some items were added by heuristic models, following business rules, and the task that was set is that, okay, there's a large volume of data. You somehow need to work with it. It has so much potential, so many hidden opportunities, but because we run it in Excel, we can't get all the capabilities for quality forecast. Plus, heuristic models are quite often not very good at making predictions. A lot of manual work. And what else? Once the model has given a forecast in Excel, you needed to wait some time, maybe a month, to see how close it got to the theory, because there are no capabilities for testing. So this is a graphic schematic of this process. A financier would manually load data from the OLAP cube to Excel, and then it would load it into the report distribution system. This is how it happens all the world, thanks good old Excel. So we had a problem when introducing ML, that firstly, reduce routine work. It should all be happening automated. Well, of course, we understand that if we have too much product experience, then you can't automate it immediately. So we were just improving the share. Machine learning has another drawback. It's a lack of transparency in calculations. Well, the manageability of such models actually falls to a situation where whatever forecast you wanted to get, you get it as a basis for your actions. Also, transparency of the model and manageability were tested. And also, all branches important. So we used to have a large chain or network in Moscow and just small outlets outside. Well, you have to deal with all of them. For instance, take the task of acquiring, where we had source data about terminals, and we have a plastic card, and we need to forecast the commission revenue. Financiers have a model like this, but with an error. The error was 8 to 9%. So what's an error of 8 to 9%? Considering Sberbank revenue, it's an amount of several billions of rubles. And it's clear that, your bonus will depend on it, the KPIs and performance of your business unit can be misinformed about the current situation based on the prediction that has not been done enough. So the erroneous forecast is it actually forms the foundation for wrong actions and management decisions. Our first approach when we started implementing the machine learning model, basically it's a classic time series. We tried different algorithms, Salima, exponential, smoothing, linear transforms. So seeing the model that converts data from Teradata to SQL, then it gets to Python. So we ran a forecast, loaded it back to SQL Server, and so the user can now see. Because there are too many values, it's not an option to do it manually.
Plus the fact we consider that a problem as well. Because, there was always something wrong with the forecast. We just need to change it and recalculate it, but we have a long-term model, which was a problem. So we decided to drop some of those because they were really giving us a hard time. And as far as the time series models are concerned, either we make a prediction from values or we have some future values, future predictors, if we operate in macroeconomic environment, for instance. With the first release given to the finance expert who had been accustomed to Excel spreadsheets, he said, that finance guy, well, guys, I can't really affect these values. What am I supposed to do with them? And also the people from the bank are asking me, how come you got that report? Because they didn't really know, because previously they knew how to work with the Excel spreadsheets and intuitively they knew how to use it. So he said, no, I don't trust this model. And we went along and we decided to interpret that model. As we interpreted the model, as far as this interpretation goes with the machine learning, either we just need to explain to a person how these algorithms really work, or if it's a finance expert, they've got their own problems. So we decided to work with a different area and how to explain to the people why this model had forecasted such end values. Why did we decide to put it into a new driver-based model? We measured what would be the global amount of rubles in all of the banks, in all of the terminals, and all of the ATMs, how many people, how much money they spent through the terminals. And we figured out 4 drivers applied to that. By combining these drivers and multiplying them, we were able to pull off different values we needed. For instance, a share of other banks' terminals is 1% of terminals by Sberbank, and commission revenue is just a few drivers multiplied. That's how it works, and the advantage of this model stands for explaining to the business the situation in the market. For example, oh, right, the amount of rubles is going up because of acquiring issues, Sberbank is going down, or somewhere because of acquiring, Sberbank is going up. So it explains such things, and after brushing it up, this model starts looking like this, and we have visualized in Excel its ML part. Okay, finally, this end user says, I understand it, but I really cannot affect this forecast. How am I supposed to affect it? And I don't have a chance to influence this forecast anyhow, and I don't trust it, and I don't believe it. That's what the user says. To trick the user, we decided to do the following. We also had to dump all of the previous ML learnings that we had previously. Of course, we were using some methods which were previously applied. It's the hierarchy model. We decided to use it in different ways. First of all, we make Sberbank's forecast, and we get it from HQ, and then these Sberbank drivers are used as predictors. For example, we have a linear model, and the predictor for it would be a forecast for the entire network, a correlated one, but not all of the affiliates, not all of the branches were correlated, so we had to come up with data sets. But these are technical details. I'm not going to stop at those because, you know, there's quite a lot of interesting specifics, and of course it requires a dedicated presentation. But what we ended up with was managing the model with a very small number of tools. For example, this is the chart which needs changes to be introduced to change the entire the entire forecast. And we don't need to have all of the values. The finance expert just looks at them and they understand what exactly they need to change in the future. For example, they know that the tariff is going to change, and somewhere they will introduce these changes. For example, they know the bank had adopted some measures to increase its presence, its share in some of the regions of Russia. So the general model of this model looks like this. We have added a few stages here. First of all, we make a forecast for the upper level, then we make adjustments, then we cascade it down the branches and put it into the report distribution system. Okay, we've figured out with the previous wishes of the user, but there is yet another comment from the user. They say this model is very inconvenient to use. After all those SQL changes introduced, they would have to go to the data scientist and ask them to relaunch the model. So they would have to recalculate the model. And initially we said, okay, let's just teach our finance expert to teach them how to work with these tables. And the finance guy said, no, I'm not going to do it. So we decided to take a new step, which continued changing our application. It was about the development of a web application. We decided to use Flask plus React, and we launched it on the server and with the custom access through REST API. We did reinvent the wheel there to be able to make adjustments there so that the finance people would see how the ultimate forecast of the bank would change. It all looked beautiful, but it was very inconvenient to make calculations for a human being and introduce changes there on their own. For example, I'm a data scientist. I know how to work with JavaScript, and I did tackle front end, but it was not my thing to do, so we'd have to find a front end person. And once we realized that there would be an idea helping us to work with these interactive graphs, that was the thing. But we decided not just to import Excel there, but it was just at that time. And finally, as we speak about the products for finance people, we still came back to Excel. We had put this option of launching a command to exchange data via SQL server. And I remember using VBA for programming like 15 years ago, so it took me 2 days to come up with the entire interface. It was just a matter of prestige for me. Okay, yes, I'm working with Excel, but then I stopped having any problems with the users, and nobody ever disturbed me any longer, asking me how come this model is making wrong forecasts. Please relaunch it. No, instead, those people would brush up the interface on their own, and they needed to check some additional values, and immediately they did the calculations right there. They would put it into the top-level model, launched that, and ended up having a forecast. That's all. They quickly checked it. Everything was fine and dandy. They clicked a button and it uploaded to the system of all of the reports. And another advantage is that it was intuitively clear to understand that interface. We didn't have to reinvent anything regarding the interface. It really did save time. And later we started using this approach to forecast all the other articles. We have an expert who possesses some knowledge, and we would just put this model into some kind of a driver model, which is convenient for them to perceive. And then we'd give them this interface to manage with this small number of tools and levers. It's very easy to come up with such interfaces, as it turned out, and we increased the share of the automation of Sber's revenue part. This method proves to be the most winning one. It combines the strength of machine learning and the strength of human expertise. Hooray to artificial intelligence. And in the end, I would like to say, as the DS developer, it's a matter of prestige for me to use state-of-the-art technologies. But when I started trying to implement all of these state-of-the-art solutions with interface or with machine learning, we used to have those neurals, but we decided not to drop them, and we decided to start with simple ones, simple solutions. We were more about focusing on data set. So good old Excel in the world of finance will remain for a long time, sure, because for financial people Excel is a very convenient, understandable tool, and any interface there, even for machine learning, is clear. Thank you very much.